In this video, I'm going to show you how to model the part for the SolidWorks Advanced Modeling assignment. The first step to modeling anything is to study the drawing, unless you're making the model from scratch. So looking at this drawing, we have to figure out the different features we need to create in order to make this part. So what I see, we have a shaft for the ball screw, which has two protrusions on each end. So really we need to go ahead and model a round part with a revolved protrusion that includes the 375, the 1 inch, and the 1875 diameters. I'll include the chamfers on the same revolved protrusion. So that'll go ahead and create the major part. Next, we're going to use the swept cutout function in order to make the ball screw, the radial cutout in the ball screw. To do that, we have our screw pitch, our ball screw radius, and the diameter and the length of the part known. So we can easily create a helix and then sweep that around this 0.0875 radius around that helix. Last but not least, we'll go ahead and create the 832 UNC thread by a depth of 0.5 using the hole wizard, and then we'll go ahead and use the circular pattern option to pattern the rest of the other four. So let's go ahead and move on to SolidWorks. Moving on to SolidWorks, we're going to go to File, New. We're going to pick Part, press OK. At this point, we have to model the revolve on the appropriate plane. So going back to SolidWorks, you'll see I'm going to model it on the front plane. You can pick the top plane as well. So to do that, moving back to SolidWorks, we go Revolve, Front Plane, and I'm going to use my line tool to sketch out half of the profile, the circular profile. At this point, I'm going to close the profile, press Escape to end my line tool, and grab a center line and drag a horizontal center line out in the opposite direction so I can use that to dimension. Now, looking at the drawing, I'm going to start with the linear distances first. I'm going to do 0.5, 6.0, and then 6.75. So moving back to SolidWorks, we're going to make this, we're going to use Smart Dimension, we're going to make this dimension 6.0. We're going to make this dimension right here 0.5. And then last but not least, we go from here to the final end of the part and make that 6.75. Next, looking back at the drawing, you're going to see we have to have a 375, a 1 inch, and a 0.188 diameter protrusion. So when I move back to SolidWorks, if I use my Smart Dimension tool and I dimension from the top to the center line and drag below the center line, I can give it the diameter of 0.375. Now, if I go from the top down, it remembers that I'm creating diameter dimensions, and I can key in 1.0. Now, looking at this line, it started to overlap itself. So what I can do is press Escape, and I can drag it upwards, press Escape to end the Smart Dimension tool, and drag it upwards so it looks more like the profile. Because remember, it wasn't fully defined because it was still blue. So now I use Smart Dimension to go from center line to the horizontal line, drag down, and type in 0.188. Enter. Looking at my drawing, I have it fully defined. Now let's go ahead and put the chamfers on it. So moving back to SolidWorks, you'll see that we've got two 10 thou chamfers, and the screw thread ends have a 50 thou by 45 degree chamfer. So I move back to SolidWorks. I can create chamfers in the 2D sketch environment by going up to the Fillet tool, clicking the drop-down menu, and selecting Sketch Chamfer. At this point, I'm going to type in 0.01, tab to accept it, zoom in and click on the endpoint of the shafts. Next, I'm going to change my chamfer size to 0.05, come back and click on the other endpoints of the ball screw. and hit check mark. At this point, I've fully defined my sketch with all the chamfers, so I'm going to hit exit sketch. Now I want to revolve a full 360, so I'll leave 360 degrees in there and hit my check mark. You'll notice we've got the main blank for the ball screw. Next, we're going to create a swept cut. To do this, I'm going to create two external sketches, both a path and a profile, and then use the swept cut tool to cut the profile along the path. So my first thing I want to do is draw my path. My path for this ball screw, going back to the drawing, is going to be on the outside 1 inch diameter. It's going to be the diameter of a helix I need to create. And that helix will have a 0.250 screw pitch. So let's move back to SolidWorks. When I go ahead and I click on helix, it asks me to click on a plane. We want to go ahead and click on the plane on the outside of the part and press spacebar, normal 2. Now, all it's asking for in this sketch is the diameter of the circle that you want to create the helix. So the helix's diameter. So what I'm going to do is I'm going to click on Convert Entities, click on the outside diameter of the part and hit check mark. That way, if I ever change the diameter of my ball screw, my helix would change the size as well because it's associated with it. At this point, I'm going to move back over to isometric and hit exit sketch. Now it starts creating a helix down my part. One of the more important things is the start angle. We want to make sure the start angle is at 0, 90, 180, or 270 so we can start the profile sketch directly where the helix starts. So notice by default mine was stuck at 180 degrees. Now our pitch is going to be 0.25 inches. We want the helix to extend all the way off the part, so I'm going to go ahead and put in 30 revolutions. Notice it'll go off and start off the part because we're cutting the entire shaft with a round profile. At this point, I've set up all my variables for my helix. I'm going to hit check mark. So now I have a helical path. Let's say over in the design tree we wanted to represent helix with an actual name called path. I can right click, go to feature properties, and type in path and hit OK. Therefore it makes sense. That's an optional thing that'll help you keep track of all your features in your feature-based modeling tool. Now, looking at the part, you'll see the helix starts here and ends here, or you can say it starts here and ends here. It doesn't really matter. But we want to draw the profile sketch normal to the start of the helix. So when I look at my planes, I don't want to use the top plane, I don't want to use the front plane. I'm going to use the top plane in my example. So I'm going to click on top plane, go over to the sketch icon and click sketch. Therefore, I'm now sketching on the top plane. At this point, I'm going to press spacebar and normal 2 and move on in and use my circle tool, connecting the center of the circle to the end point of the helix. And now I've got to go ahead and size my circle. So looking back at the drawing, you'll see that it's a radius of 0.0875. When I move back to SolidWorks, I click on Smart Dimension, click on the circle, drag it out, and let's say I'm bad at math, I could type 0.0875 times 2, which would give me the diameter of the part when I hit check mark. That's all we really need for the profile sketch, a circle, because we're making a ball screw, which we'll talk about in the anatomy of a CNC machine later on in the quarter. So now, when I go ahead and I exit this sketch, instead of calling it sketch 3, I'm going to right click and I'm going to call it, hit feature properties and call it profile. Press OK. Now I've got a path and a profile which I can cut out of my part. So I go over to my features, I select swept cut, and I pick my profile and my path. At this point, it's going to cut the round profile out of my part. So when I hit check mark, you'll see my ball screw is fully formed. Now, the helix is kind of in the way of my view. So what I can do is I can right click on the helix and click on hide, and you'll see only the part. Now, last but not least, moving back to the drawing, you're going to see we're going to do 5 by 72 degrees for our bolt hole circle pattern. So our bolt hole circle pattern actually is at a diameter of 0.5 inches. And we have 5 8-32 UNC screws that are a ½ inch deep. So we're going to create that using the Hole Wizard. In fact, I'm going to create one using the Hole Wizard and then show you the circular pattern, feature pattern option. So let's move back to SolidWorks. You'll notice you have to select the correct side, make it visible. Now we're going to go to the Hole Wizard. In the Hole Wizard, I want to pick not a counterbore hole, not a countersunk hole, or a regular hole. I'm going to pick a tapped hole, straight tap. Using the ANSI inch sizes, I move down and I'm going to make a number 8-32 thread. Remember, any thread smaller than 1/4 inch gets specified by a number size. So number 832. Looking at the drawing again, you'll see our 832 goes 0.5 deep. That is going to be the thread's depth. We're going to let SolidWorks figure out the depth of the drilled hole on its own. So when I select blind hole and I type in 0.5 deep, it'll go ahead and make the drill depth 90 thou deeper than the actual thread depth. So we don't have to worry about how much deeper to make the drill go in order to make that thread in our part. Although you should know how that works based off the pitch and the type of tap that you'll be using. So now that I've sized the hole, I'm going to give it a location or a position by clicking on the Positions tab, clicking on the face that I want to go ahead and make the threaded cut in. Then I'm going to press Spacebar and Normal to bring it normal to my view. Now because I'm making a ½ inch diameter bolt hole circle, I'm going to make my first bolt directly in line with my y-axis, or directly vertical above the center of my part. Now to go ahead and end the circle tool, I press Escape, then I use Smart Dimension to dimension the radius of that ½ inch diameter bolt hole circle pattern. So when I click my mouse button, I'm going to go ahead and type in 0.25 because that's the radius of the ½ inch diameter pattern. At this point, you could also do a sketch pattern. However, I'm going to go ahead and show you a different feature out in the features menu. So I'm going to hit my check mark and create one hole. Now, in order to make a pattern of these holes, or this hole, make 5 of them, I'm going to click on Circular Pattern underneath the Linear Pattern drop-down menu. My circular pattern is going to end up being around a circle, so I have to pick any circle that the pattern is concentric to. Hence, I'm just going to pick the front circle of this protrusion down here. That gives me the circle that I'm going to pattern the axis about. Now, if I did instant spacing, I could go ahead and give it a certain amount of degrees and it would make those holes spread out that certain amount of degrees. However, ours goes a full 360 around, so what we're going to end up doing is we're going to go equal spacing, and instead of 30 of them, we're going to type in 5. So I've got 5 pattern, it includes the one that you've made, a full 360 degrees. Now the features are the Hole Wizard feature. You can pattern pretty much any feature as long as it makes sense. So when I hit the check mark, you're going to see we've got all of the threaded holes created in the part, the 832 screws. So now I'm going to hit spacebar and isometric, and you'll see we've got our model fully created in order to make the engineering drawing that'll be due in your next CAD lab. So the last step is to go File, Save As, and you save your document in a known location. At this point, give me one more second to find my file location. Save it there. And now, join me next time for the video on how to go ahead and make the engineering drawing for this part. Have a great day.